I'll teach you everything you need to know about size in 5 minutes. We've seen a variety of different values properties taken. Now I'm going to show you one of the most common ones. This is known as vector 3. Roblox by default is a 3D world. It has an x-axis going left to right, a y-axis going up and down. And if you've done anything with graphs before, it's the exact same thing. You know you have your x-axis going left and right, and your y-axis going up and down. The only difference is there's a third axis, the z-axis, which goes forward and backwards. If we want to change a part size, we can do it in all 3 dimensions. Let me remove this part and add a new one. Show you that by default, the part size is 4 studs in the x-axis going this way, 1 stud in the y-axis going up and down, and 2 studs of depth going this way. If you know how big a stud is, each one of these little squares is 1 stud. They're 1 stud away each. So as you can see, it's about 1, 2, 3, 4 studs, and about, if we line it up, 2 studs this way, and yeah, 1 stud high. Let's say we want to use the script to change this part size. Instead of being 4 by 1 by 2 to be 20 by 1 by 2, I'll show you how to do that. Let's just assign part to be equal to workspace.part so we don't have to write workspace.part every time. Part.size equals vector 3, and then you write dot new, as we've been doing with some of the other properties like color, and then in parentheses, and this takes in 3 arguments, as you see right here, 1 for the x-axis, 1 for the y, and 1 for the z. And we said we wanted this to be 20 by 1 by 2, so you just write 20 for the x-axis, 1 for the y-axis, and 2 for the z-axis. And now when we run this, bam, it gets elongated to 20 in the x-axis. Obviously, we can make these values whatever number we want. As long as it boils down to a number, we can make it to whatever. Let's make it into a 30 by 30 by 30, and this will be a giant cube. Whoa, look at that. And yeah, you can even do some cool stuff. If you set it to 15 by 15 by 15, then you wait, and then make it 20 by 20 by 20. Then you wait, you make it 25 by 25 by 25. You can get some cool effects just by messing around with some of the other features we already learned and including them with this new one. You can make it grow. Pretty cool. I'm going to change this part to green, and I'm going to make a new part, change it to red, and I'm going to make this a random size, and I'm going to make this a random size. And this green part, I'm going to rename it to part A, and this part, I'm going to rename it to part B. And don't forget, now we're not accessing workspace.part anymore because that's not a thing. We're going to access workspace.part A. And we can name this to part A. We can name this to part B. Goes workspace.part B. So now we're accessing both of those parts with the variables. And let's assume we have part A here, but we want this to be the same size as this. You don't have to come in here and look and then copy and paste the size. You can just easily write part A dot size equals part B dot size. Because what kind of value is this that we want to change? It's a vector 3. And what kind of value is part B size? It's also a vector 3. So we can change the size to anything. As long as it's a vector 3, it'll work. I'll show you that. Let's run this. Bam, it got transformed into the same size. They're twinning and winning. I don't know what that means, but it sounded nice. Remember those grayed out properties I told you that you can read, but you can't really change? If you want to change the size in just one axis, you can't just do size.x and equal size.x because this can only be read. It cannot be assigned. But you can use it, but you cannot assign it. I'll show you what I mean. I want this green part's x value to be equal to this part's x value, but I want everything else to be the same. So one way we can do this is by setting it equal to vector3.new. We want part A's x value to be equal to part B's x value. So since we're changing part A's size, we're going to set the x value to be equal to part B.size.x value. And we want part A's y and z to stay the same. We can just put in the size.y and the size.z. This will make a new vector 3 that's made up of the part B's x-axis and both part A's y-axis and part A's y-axis. So the y and z-axis of this part size will stay the same, but the x will be copied from part B, and I'll show you what that looks like. Bam. So it's the same amount of length this way, but it still kept part A's original thickness and height.